This is pre-calc, section 6.4, matrix properties and operations. A matrix is classified by its dimension, i.e. the number of rows and columns it contains. This is called the order of the matrix. So here's a matrix right here. This has 2 rows, 1 row, 2 rows, and 3 columns. Therefore, this is a 2 by 3 matrix. The number of rows is given first. A matrix with equal dimensions is called a square matrix. This has got 1, 2, 3 rows and 1, 2, 3 columns. This is a 3 by 3 matrix, and it is called a square matrix because those dimensions are the same. A matrix with a single row is called a row matrix. Makes sense. All it has is 1 row. It is a row matrix. If all it has is a 1 column, it is called a column matrix. And let's look at these dimensions just for a second because sometimes people get them confused. This is 1 row by 1, 2, 3 columns. Now they're very short columns, but those are 3 columns. This has got 1, 2, 3, 4 rows, but only 1 column. And a matrix that contains only zeros is called a zero matrix. Another important fact about matrices that is pretty intuitive is that 2 matrices are equal if they have the same dimension and if the corresponding elements, position by position, are equal. Basically, they are the exact same matrix. So the matrix 1, 2, 3, 4 is equal to the matrix 1, 2, 3, 4. That's the only way you can say the 2 matrices are equal is if they've got the exact same elements in the exact same position. So 1, 2, 3, 4 is not equal to 4, 2, 1, 3. They are the same dimensions, but they are not equal. There's a couple problems in Math Lab like this that tell you matrix A is this, matrix B is this, and it wants us to determine X, Y, P, and Q such that matrix A is equal to matrix B. If matrix A is equal to matrix B, that means position by position, the entries are equal. So that's the first position to the first position is telling me X equals 2. Right here, 1 is in the same position as Y, so 1 equals Y. On the bottom, P is equal to -1, and Q is equal to 0. So pretty simple, you're just lining them up position by position. You will also be asked to name the dimension or order of each matrix and then determine if it's any of the special types we just looked at on the other screen. So this has got 1, 2, 3 rows. It has 2 columns, therefore it is a 3 by 2 matrix. This one, and there's nothing fancy about that. This one has 4 rows. It has 1 column. This is a column matrix. This one has 1 big row by 4 columns, and it is a row matrix. Operations on matrices, adding and subtracting matrices, very easy. It is just a matter of adding position to position, but the dimension of each matrix must be equal. They have to be the same dimensions because we're going to have to add these matrices or subtract them position by position. So a 2 by 3 matrix can only be added to another 2 by 3 matrix. A 4 by 2 matrix and a 2 by 4 matrix cannot be added or subtracted. They're not the same dimension. So you're asked to find each sum or difference if possible. This is a 2 by 2. This is a 2 by 2. So adding these is certainly possible, and we will do them position by position. So 5 plus -4 is 1. -6 plus 6 is 0. 8 plus 8 is 16. And 9 minus 3 is 6, and that's all there is to it. So adding matrices, very, very simple. Subtracting, I better look at the dimensions. This is a 2 by 2. This is a 2 by 2. So that says, yes, I can subtract them. And all you need to be careful with here is the arithmetic sign-wise. So you might want to write this out rather than, like on this, I just underlined 5 and -4. This is -5 minus -3. Minus and minus goes to plus. -5 plus 3 is -2. This is pretty simple. 6 minus 2 is 4. 2 minus 5, if you got to write it out or enter it in your calculator, that's fine. 2 minus 5 is -3. And the bottom is 4 minus -8. Minus and minus goes to plus, and that will be 12. There's something called scalar multiplication. And a scalar is just a real number that is outside of the matrix, and all you're doing is distributive property. So 2 in front of this matrix is going to create another 2 by 2 matrix where each of the entries has been doubled. So -10, 12, 4, and 8. Multiplication of matrices gets a little bit more involved. And number one, you have to check the dimensions of your matrices to see if they can be multiplied. It says the product AB of an M by N matrix, I'm going to write this right there, right here, M by N matrix, times an N by K matrix. So these are the dimensions of matrix A. These are the dimensions of matrix B, and they are only able to be multiplied if the middle values here match. This is an N, this is an N. That says, yep, I'm going to be able to multiply these matrices. Furthermore, my answer matrix dimensions will be M by K. So we want to see if these matrices, we don't have the matrices written out, you don't know how to multiply them yet, but the number one thing to check is if they can be multiplied. So you check right in here. As long as those two numbers are the same, the dimensions of your result will be a 2 by 6. Here, the 6 does not match with the 1. This is not possible. Here, the 2 matches with the 2. That means they are able to be multiplied, and my answer matrix will be a 4 by 3. You will understand in a little bit once we start multiplying why these dimensions have to match up the way they do. So what this process is saying is that the number of columns of matrix A must equal the number of rows in matrix B. The number of columns in matrix A must equal the number of rows in matrix B. And there's a reason for that, and it has to do with the process of multiplying matrices. So it sounds kind of complicated, but once you do several, you should be okay. You must multiply each entry of a row by corresponding entry of a column and then add those products. So sounds weird. The first thing I'm going to do is write matrix A right next to matrix B. And I'm going to double check that I really can multiply these. This is a 2 by 2. This is a 2 by 2. And based on what we just went over, the 2's match in the middle. The answer matrix will also be a 2 by 2. You might even want to put the little blanks down and label this down here as a 2 by 2. Anything you can do to help you get the entries in the right place. Now, we must multiply the entire first row times the entire first column. And here's what I suggest you do. You can take a pencil or a pen or a piece of paper and cover up the bottom row, because we're not going to use that right now. Cover up the second column so that all you are looking at is the first row times the first column. First row times the first column. And you are doing it entry by. So this is 3 times 5 plus 1 times 3. Now where'd that come from? The first thing times the first thing plus the second thing in the row times the second thing in the column. Arithmetic wise, 3 times 5 is 15. 1 times 3 is 3. Add that together, gives you 18 in that position right there. Looks weird, but once we do a couple of them, I hope you will catch on. Keep the second row covered up. I'm not using it just yet, but move this over, and you are going to multiply the first row times the second column, position by position. So this is the first thing in the row, which is 3, times the first thing in the column, which is 0, plus the second item in the row times the second item in the column, 1 times -1. 3 times 0 is 0, plus 1 times -1 is -1. 0 plus -1 is -1. We are finished with the first row. Now, just another comment on this is when we did this, this was first row times first column. The answer went in the first row, first column of the answer matrix. Then when I did this, this was first row times second column. The answer went in this position, which was the first row, second column of the answer matrix. Now I want to move my little cover up here and get my answers for the second row. So I start by doing second row times the first column. And that arithmetic is -2 times 5 plus 6 times 3. Now what is that? That's the first thing in the row times the first thing in the column plus the second thing in the row times the second thing in the column will give us -10 plus 18, which is 8. It's going in that position because that was the product of the second row, first column, goes in the second row, first column. Keep the second row uncovered. Slide your cover over here, and you are now doing second row times second column. -2 times 0 plus 6 times -1. That is a -1. It got covered up by that blue a little bit. So that is the first thing in the row times the first thing in the column plus the second thing in the row times the second thing in the column. So that is 0 minus 6 gives you -6. And if you've never seen matrix multiplication before, that looks a little strange, but once you do a couple of them, hopefully you can catch on without having to write all these steps down. Also, hopefully you won't even need the covers anymore. In a classroom setting, I can show you, with where I put my fingers, how I keep this straight without having to do all of this. I want to do the product BA, and before we do the product, we want to check the dimensions. That's a 2 by 2 times another 2 by 2. Because the 2's match in the middle tells me these are multipliable, and my solution matrix will be a 2 by 2. So I'm laying out the blanks, and I know this will be a 2 by 2. You might also be thinking right now, well, hey, why bother doing BA? We already did AB. Well, you're going to see in a second that multiplication of matrices is not commutative, and what that means is order matters. You need to put the correct one on the left, the correct one on the right. This is BA, so this is matrix B that's in the left position. This is matrix A that's in the right position. So now I'm going to do my little covering. Cover the bottom row and cover the second column for right now. 5 times 3 is 15, plus 0 times -2 is 0, gives me a 15 right there. So with this one, I'm not writing out the multiplications, I am writing out the product and the sum. Now I want to do the first row times the second column, and that will be 5 times 1, which is 5, plus 0 times 6, which is 0. That gives me a 5 right there. Now let's move our covers so that the bottom row is exposed and start over with the first column. This is 3 times 3, which is 9, plus -1 times -2, which is 2. Remember what you're doing. That's the first thing in the row times the first thing in the column plus the second thing in the row times the second thing in the column. So 9 plus 2 will give me 11 in this position. It goes in this position because it is the product of the bottom row. First column goes in the bottom row, first column position. Keep the top row covered up, but we do need to move the cover on this over here. And now we are doing first in the row times first in the column. 3 times 1 is 3, plus second in the row times second in the column. -1 times 6 is -6. So 3 plus -6 is -3.